This is an Algebra 1 Summer School, Unit 4, Lesson 5 practice video for linear versus exponential functions practice. All right, in this practice video, I'm going to do just number 1A, C, and D. If you have questions other than 1A, C, and D, you'll have to either check at the key that's posted on Canvas or come into office hours and ask your instructor for help. This first page doesn't have any problems on it. What it does is it re-explains the difference between a linear function and an exponential function. It says, remember that a linear function is of the form y equals mx plus b, where b is the starting value and m is the slope. An exponential function is of the form y equals a times b to the x, where a is the starting value and b is the growth rate. Okay? What we have here in these three problems are three sets of tables that we need to decide if they're linear or exponential. Okay? We have a starting place here of 2. So I'm going to decide if I'm adding or multiplying to get from 2 to 5, 5 to 8, 8 to 11, and so on. It appears that I'm adding 3 to get from 2 to 5, 5 to 8, and so on and so on. So that 3, because I'm adding it, makes this a linear function. If I'm going to write a linear function, it needs to be in the slope-intercept form, y equals mx plus b. Well, my slope is 3. That's the number that I'm adding every time. So my equation is y equals 3x. Now the y-intercept is given to me. That happens where x equals 0. So plus 2. That's it, question A. Now let's look at question C, linear or exponential. Well, let's see, if I'm subtracting, I'd be subtracting 5 to get from 10 to 5, and then subtracting 2.5 to go from 5 to 2.5. So that doesn't seem correct that it's going to be linear. So all I'm left with is that this is an exponential function. In order to find the growth rate for an exponential function, you take the second number in the table and divide it by the first number. That gives me 1/2. Or 0.5, either one, it's equivalent. Think about it. If I take 10 times 0.5, I get 5. 5 times 0.5 gives me 2.5. And half of 2.5 is 1.25, and so on and so on. So since this is exponential, I need to figure out my starting value. The starting value here, where x is 0, is 10 times the growth rate of 0.5 to the x power. Finally, let's look at question D. I have the starting value of 12, and I need to figure out how I'm changing. Right? It appears that I'm subtracting 4 each time that I go from term to term. So since I'm subtracting the same value each time, this is a linear function. The slope of the linear function is -4. I put the x after the slope. And I have a starting value of 12, so plus. All right, that's the practice, the last practice for Unit 4. You need to make sure that you can do all of the notes and all of the practice really well, and when you're ready, you can come on into office hours and try the unit test for Unit 4 exponential functions.